Welcome to the Deep Dive. Today, we're peeling back the layers on something that might seem a bit dry at first glance, a government request for proposals, an RFP.
Yeah, sounds thrilling, right?
Exactly. But seriously, you and I are going to dig in because this isn't just bureaucratic text. It's actually a blueprint, It
Yeah.
shapes big national projects, even parts of our everyday lives, in ways we don't always see.
That's right. These RFPs, they're really powerful, but often fly under the radar. They show you not just what the government is buying, but why, the strategy behind it.
Okay.
And this one gives us a fantastic window into NIST, the National Institute of Standards and Technology. It's like getting a peek behind the curtain at how progress actually happens.
So NIST, let's start there for anyone maybe not familiar. This document comes from what's NIST all about? What do they actually do?
Right. So NIST is a federal agency, but non-regulatory. It sits within the Department of Commerce.
Huh.
And their main job, their core mission, is really to boost U.S. innovation and industrial competitiveness. They do this by pushing forward measurement science, standards, technology, basically things that help the economy and, frankly, improve our quality of life.
Government science standards.
Okay.
And the specific thing we're looking at today, this deep dive, it focuses on one of their contracts. It's called an IDIQ, Indefinite Delivery, Indefinite Quantity.
Right, the IDIQ. And looking at the purpose section here, it's immediately clear this isn't small stuff. It lays out a pretty huge scope, doesn't it?
Oh, yeah.
Developing measurement science, IT models, IT standard reference implementations, IT tools,
Right.
Standard reference database applications, SRDs, even archiving scientific info. It feels like they're building fundamental tech infrastructure.
They absolutely are. That's a great way to put it, foundational work.
Okay, let's try and unpack some of this because, terms like IT model and standard reference implementations, they sound very technical. What do they actually mean in practice? What's the real world impact for us? Yeah, good question. So an IT model here, it's basically a representation. Think of it like a blueprint for a standard or maybe an IT architecture. They use something called UML, Unified Modeling Language.
Yeah, well, okay.
It's like the really detailed drawings an architect makes, but for a software system or a process, it shows how everything fits together, how it should behave before you write code. It ensures everyone's on the same page. Consistency, clarity. That's the goal.
Right, the blueprint stage.
Exactly. And then the IT standard reference implementations, those are the actual computer programs, the applications that are built directly from those models. They're designed to perfectly match a specific standard.
I see.
And the document gives a really concrete example, actually. NIST built both the UML model and a reference implementation, they called it SCREBA, for something called the IPC 1752A Materials Declaration Standard.
Okay, Scribo, what does that do?
Well, this is pretty cool. It helps companies share information about the materials inside their products. Think about supply chains, right? Global supply chains. This standard and the SCREBA tool makes it easier to track what materials, what chemicals are in things. So the phone in your pocket, your car. SCREBA helps create transparency. It's a free, open source tool, Java-based, helps manage all that data. It's kind of a quiet step towards more traceability and trust in manufacturing.
Wow, okay, that really makes it tangible. So following that thread, what about the standard reference database applications, or SRDs? You mentioned those. What kind of data is in there? Why are they important?
SRDs are super critical. They contain really carefully checked, reliable data, usually physical or chemical properties.
All right.
This ties right into NIST's core job. They're the main federal source for this kind of reliable scientific reference data. They coordinate it all through the National Standard Reference Data System. There are like 80 of these databases.
80. Wow.
Yeah. Some are free online, like the NIST Chemistry Webbook, that's SRD 169, or the Chemical Kinetics Database, SRD 17. Others you might have to purchase, like SRD 31, the Phase Equilibria Diagrams Database. But this isn't just random data. It's the foundation for a lot of science and engineering. When researchers are developing, say, a new material or checking calculations for a drug, they often rely on this NIST data. It ensures everyone's working from the same reliable facts. It's kind of the bedrock.
It's amazing how NIST seems to be involved in so many different areas.
Yeah.
This RFP lists a really wide range of measurement science and technical domains. How widespread is their influence, really? What jumps out at you?
Yeah, the scope is huge. The document breaks it down into three main buckets, which helps to grasp it. First is health and biosciences.
Okay.
Here, they're working on health IT testing infrastructure. So think tools for testing electronic health record systems, making sure they work together properly, interoperability.
Right. Crucial for healthcare.
Definitely. Also, supporting personalized medicine by creating standards for data exchange in biosciences. And a really big one, The Materials Genome Initiative.
Materials genome.
Yeah, developing the science, the tools, the standards to speed up how we discover and develop new materials. Imagine making better solar cells or lighter airplane parts much, much faster. That's the idea.
So from our health records to the actual stuff things are made of,
Yeah.
NIST is there.
Yeah.
It really changes how you think about standards. It's way beyond just nuts and bolts.
Exactly. Then the second area is commerce. This is huge, too. They're working on cyber-physical systems. The smart grid is a good example. They model the standards, build tools to check if the software conforms, helping keep the grid stable and secure.
Okay, smart grid, that makes sense.
Cloud computing, too. NIST develops standards and guidelines for how the federal government adopts cloud services securely. And that eventually influences the private sector, too. And then, really critical these days, voting. They work to accelerate voting system standards and guidelines and even develop test tools for the voluntary voting system guidelines, VVSG 1.0, 1.1, 2.0.
Voting systems and cloud security, I mean, those are fundamental to public trust, to our infrastructure. It shows how deep NIST's work goes into, well, our digital lives and even democracy. It's not just technical specs, it's about trust.
Absolutely. And under commerce, there's also computer security generally, advanced network technologies, improving internet robustness, identity management, all that.
Okay, and the third category?
The third is physical sciences and technology. This includes managing those SRD applications we talked about, getting that critical scientific data out there.
Right.
Also, computer forensics and software assurance, developing tools for digital forensics testing, methods to identify software, how investigators figure out what happened on a computer after a crime. NIST helps develop those methods.
Fascinating.
And finally, something called NIST objectives. This is more internal, automating administrative tasks within NIST using custom web apps so their scientists can spend more time on science and less on paperwork, basically making themselves more efficient.
Okay, now this is where it gets really interesting, I think, for anyone who might actually want to work with the government or even just understand how these huge projects get set up. You mentioned it's an IDIQ contract, indefinite delivery, indefinite quantity.
Right.
And all the task orders are firm fixed price. That's not just jargon, right? An IDIQ is like a flexible shopping list for the government.
Kind of, yeah. An on-demand catalog of services.
And firm fixed price means the contractor bids a price, and that's it. They have to stick to it, even if things get complicated. So they need to be really sharp with their bids.
Exactly. There's risk involved for the contractor there.
So financially, how big are we talking here? And for how long does this run?
Well, the document states the IDIQ has a not-to-exceed amount, an NTE of $45 million. That's across all the contracts awarded under this IDIQ.
$45 million. Okay, that's substantial.
It is. And there's also a minimum guarantee for each company that wins an IDIQ award. They have to get at least $15,000 worth of orders.
Got it. And the timeline?
It's structured with a one-year base period and then 4 possible one-year option periods. So potentially it could run for 5 years total. The tentative dates mentioned were February 1st, 2021, running through January 31st, 2026.
5 years, potentially.
Okay.
So beyond the money and the structure, what's the day-to-day like for a company that actually wins one of these? What are the sort of nitty-gritty responsibilities they sign up for?
The document lists a lot, providing all the people, equipment, materials, assigning a project manager, using Redmine for tracking security compliance.
Yeah, all that's standard. And the details get pretty specific. Like travel costs, they get reimbursed based on federal rules, but the contractor has to submit receipts for anything over $75 with their invoice. It shows you the level of accounting required.
Yeah.
Very rigorous.
Now let's get into some things that maybe seem less expected, but are definitely critical operationally. I was struck by the requirement for contractors to actually process H-1 visas for foreign nationals.
And then, of course, all the strict rules for working on site. It points to needing global talent, but also the highly controlled environment of government facilities.
It really does. And the on-site work, it specifies the NIST campuses, Gaithersburg in Maryland, Boulder in Colorado, and even the Hollings Marine Lab down in Charleston, South Carolina. Standard hours are 8:30 to 5:00 Eastern, Monday to Friday. Contractors have to follow all the NIST safety rules, fire prevention, wear their ID badges visibly all the time, register their cars.
All makes sense.
And maybe obvious, but stated clearly, no using government stuff for personal business. There's also a really important clause called non-personal services.
What's that about?
It emphasizes that contractor employees are not directly supervised by government staff. They work for the contractor. And they always have to identify themselves as contractors when they communicate emails, meetings, whatever. It maintains a clear separation.
Okay, that distinction is important. Now, something that really jumped out, given the timing mentioned, the COVID-19 protocols from June 2020. What stands out to you about seeing that detailed so explicitly in a formal RFP like this? It feels unusual for this kind of document.
It's really fascinating, isn't it? A very stark reminder that these government contracts, even though they seem formal and rigid, they're actually living documents. They have to adapt to whatever's happening nationally, globally.
Yeah.
Attachment 2 lays it all out. Self-screening before coming to campus, restrictions if you have symptoms or exposure or risky travel, and then on campus, mandatory face covering, 6-foot distancing, hand hygiene. Seeing that level of detail, it just shows how profoundly something like a pandemic can reshape the practical day-to-day operations of federal science work. It changed the blueprint in real time.
Absolutely. And one more operational point, when a company develops, say, new software or generates important data for NIST under this contract, who owns it? What about the data rights?
That's a key point. The government requires unlimited data rights for all the deliverables created under these task orders.
Unlimited rights.
Yep. So basically, any new intellectual property, any data that's generated as part of the contract work, it belongs to the government. They need to be able to use it, share it, build on it for the public good without restriction.
Makes total sense for public work.
Yeah.
Okay, let's shift to the people involved. The personnel qualifications. This RFP is incredibly specific, from like a senior program manager needing a PhD or a master's and tons of experience, down through different levels of scientists, engineers, data folks, IT specialists, technicians, each with detailed requirements for education and experience.
Yeah, very detailed.
So how does a company even begin to respond to something this complex? What do their proposals actually look like? It must be a monumental effort.
Oh, it is a huge undertaking. Companies bidding put together these incredibly detailed proposals, usually in multiple volumes, typically 3 main parts. Volume 1 is non-price for the base IDIQ contract. This is where they show their technical capability, prove they understand the work NIST does in these areas.
Right.
It also covers their management approach, how they'll structure their team, manage quality, control costs. And critically, they have to detail the qualifications of the specific person they're proposing as the overall IDIQ program manager.
Got it.
This volume also lists all the labor categories they plan to offer, with the education and experience needed for each role, but importantly, no prices in this volume. And finally, past performance. They need to submit questionnaires or performance reports, CPARs, for 3 to 5 similar projects they've done before.
Okay, Volume 1 is capability management past work. What's next?
Volume 2 is also non-price, but focuses on mock task orders. The RFP actually provides 8 sample projects, like hypothetical assignments.
Mock tasks, okay.
And bidders have to write proposals for at least 3 of these mock tasks. For each one they choose, they have to detail their specific technical approach, show how they'd tackle that particular project, propose the types and number of people needed, estimate the effort involved.
So they prove they can actually do the work.
Exactly. They also have to identify the key people they'd assign to that mock task and include their resumes. It's where they really demonstrate their practical skills, not just talk about them.
Makes sense. And Volume 3, that must be the money part.
That's right. Volume 3 is the business and pricing proposal. This has all the standard government forms, SF, 1449, and so on. And crucially, the pricing. For the main IDIQ contract, they propose their maximum fully burdened hourly labor rates for every single labor category for both on-site and off-site work for each potential year of the 5-year contract. NIST even provides a specific Excel spreadsheet for this.
Wow, detailed rates.
Very. And then for those mock task orders they proposed on in Volume 2, here in Volume 3, they provide the firm fixed price proposal for each one.
Ah, the actual price tag for those sample jobs.
Yep, with a detailed breakdown showing how they calculated it, which labor categories, what rates, how many hours. If travel is involved in a mock task, they propose a not-to-exceed price for that. And really importantly, they propose a payment schedule tied to specific deliverables for each firm fixed price task.
Okay, so payment upon delivering results. That's a massive amount of information to pull together. How does NIST possibly weigh all of that when deciding who wins, what matters most?
Well, the evaluation factors are laid out pretty clearly. The non-price factors, so technical capability, management approach, the mock task orders, and past performance all together, they are considered more important than the price.
More important than price. Okay.
Within those non-price factors, technical capability and the management approach are the most important, and they're considered equal to each other. The mock task orders and past performance are also equal to each other in importance, but they weigh a bit less than technical and management capability. NIST stated they aimed to award about 3 IDIQ contracts from this, and they really favored companies that showed strong skills across all, or at least most, of those different mock task order areas. So demonstrated capability and a solid plan are definitely key.
This whole deep dive into just one RFP,
Mm-hmm.
it's been really eye-opening. It
Yeah.
just shows the incredible level of detail, the sheer scale of work that's outlined in what looks like just a dense document.
Mhm.
It's this whole intricate web of expertise and planning that you need to keep the country's science and tech moving forward. And it's happening kind of quietly, the background of everything else.
Absolutely. And this dive into just one RFP, it really reveals that underneath what looks like dry contractual language, there's this complex, often totally unseen operational blueprint. It's driving cutting-edge science innovation that really does affect our daily lives, our national future. And it kind of makes you wonder, doesn't it? Raises this question, how many other really critical parts of our society, infrastructure, public safety, you name it, are held up by these incredibly detailed and meticulously structured, but basically invisible frameworks that we rarely, if ever, stop to think about.